So what if I told you the auroral region in both hemispheres are highly symmetric? My name is Yu Hong, a third-year graduate from Dr. Yuden's group in space physics. In this study, we're talking about the inter-hemispheric symmetry of the electrodynamics in the Earth's upper atmosphere during a real storm. So I would like to thank all the co-authors here for making this work possible. I would like to start with the introduction and motivations, and we turn to the methodology, and we were interested in the inter-hemispheric symmetry of both the high latitude electrodynamics and the electrodynamics expansion to the lower latitude. And finally is a brief summary. We commonly assume that the auroral region in both hemispheres are symmetric, but this is not always the case. Especially during geomagnetic storms, the electrodynamics in the upper atmosphere can be highly asymmetric. So the empirical models, which based on the symmetric hemisphere output, and they can't capture the spatial and temporal variation in the high latitude region. So in order to better understand the inter-hemispheric asymmetry during storm time, we need better specify the electrodynamics. For example, in this study, the electric potential. So according to the Ohm's law, if we have the observation of the field and current, and the ionospheric conductance is given by the upper atmosphere Data model, then the potential can be uniquely calculated. So this leads to our second methodology, which we define as run 1 and run 2, based on the empirical model and data physics model respectively. So you may ask me how we mathematically quantify the symmetry. So we use the equation here to check the difference between the northern and southern hemisphere. So a common issue for the scientific research is which one is more important, the real data or the physics theory. So in this slide, we also explain the three questions. So for question 1, we use the satellite observation for the data model comparing. So before that, we did the pre-processing for the observational data. We removed some unreliable data based on the data quality, and we removed the baseline. So in question 2, we use the field current to dream our algorithm. And we also, based on the physical theory, we removed some unreliable data, like from the polar cap region, and we did some smooth. And finally, we answer the question 3. So does the data-based simulation result better reproduce the real situation? So let's check it out. This slide shows the data model comparing of the polar cap region electric potential. Comparing between the specifically the DMSB observation, referred to the black dot lines, and run 1, which driven by the pure model, the green lines, and run 2, driven by the data-based model, the red line. So for 4 specific satellite trajectories and for the statics result. So basically you can see the run 2, which is the database simulation, has more accurate temporal variation and the distribution, and also statically much more consistent with the real observation than run 1. And now we check the inter-hemispheric symmetry in the potential. So we show the temporal variation in both run 1 and run 2 for both northern and southern hemisphere. So basically, the run 2 has much more temporal variation than run 1, and also we show the average value for 2 hemispheres, and more important, the asymmetry index. You can see the run 2 has much larger asymmetry index than run 1. Basically, we shouldn't stop here, so we move on to the potential expansion to the lower latitude, which is the boundary. So basically, you can see for northern or southern hemisphere, the run 2 simulation has much larger, better consistent with the real observation for the potential expansion. And since we have verified that the data-driven simulation are better than the empirical model, so we can use the simulation result, the electric potential, to explain the linear figure of the variation of the boundary. So basically for the northern hemisphere, the By positive period, which is the left-hand side figure, extends to lower latitude than the right one. And opposite, for the southern hemisphere, you can see for the negative BZ positive region, which is the figure in the right-hand side, extend to the lower latitude than the left one. So this is definitely the inter-hemispheric symmetry of the expansion, which is highly depends on the specification of the electric potential in the high latitude polar region. So more accurate electrodynamics prediction is much more important. So finally, the conclusion and summary, and I would like to stop here. Thanks for your listening.